In this video, we're going to learn about average velocity. This is a vector quantity. Speed is the scalar. Velocity is going to be represented with the letter v, and it is a vector quantity. And right now we're going to discuss just the average velocity. So the velocity is not necessarily going to be constant as the object travels from point A to point B. And velocity is defined as the displacement over the change in time. So you're going to take your final position minus your initial position divided by time final minus time initial. Now notice I'm not putting a vector arrow over time. Time is not a vector quantity. You can't have negative time. We're not allowed to time travel in this course. So if you get an answer that has a negative time, that means you need to go back and double check your math. Normally it means you forgot a minus sign somewhere in the problem. In words, this would be the change in position with respect to time. So this is the difference between displacement and velocity is the with respect to time. Displacement was change in position. Velocity is now going to have the displacement change over a certain time period. Because we're dealing with a distance over time, our units are going to be meters per second. Now we're going to look at a graphical representation of position versus time. So remember, slope is equal to rise over run. So the rise, in this case the y values, is change in position. So if I want to find the slope between 2 points, I'd be taking position 1 minus position 2, or position 2 minus position 1. So that would be your displacement. And the run in this case, or the x value, would be time 2 minus time 1, or your change in time. So that tells us that the slope is equal to the average velocity. And this allows me to expand a little bit more on what I meant by the fact that this is an average velocity that is not constant with time. So if we look at the slope, so if I draw a line of best fit between these 2 points, the slope would be represented by that line. But if I took and looked at points 3 and 4 here and drew a line through those 2 points, my slope here would not be the same value as my slope here. And you can see that this one is like this one is more angled a little bit shallower. So that means that whenever you find the average velocity between these 2 points, you're going to get a different value, telling you that your velocity is not constant or that it's changing with time, and you have an actual average. So you're finding the average velocity between the 2 points you've selected. Now let's focus in on our next line. If I pick 2 points here, we would have this slope, and if I pick 2 points down here, we would have this slope, but it would be the exact same slope. So no matter what 2 points you picked to find the average velocity between, you would get the exact same value. So this line here would represent constant velocity, versus this line in here, because it's curved and not linear like the other line is, would be non-constant velocity. So you can look at the slope and you can find the average velocity between 2 points, and you can also tell whether or not the velocity is constant or stays the same value the whole way through the motion, or whether it changes throughout the motion. And our last line here, if I were to take the slope between those 2 points, you would find that the displacement values would be exactly the same since it's a horizontal line. So this means my slope would be 0, or that the velocity is 0. So with time, this object is staying at the same position, so it has no velocity.